Alright, today we're just going to look at the math for the non-horizontally launched projectiles, or those launched at an angle. It says dual credit, but of course this is welcome to everyone to watch, because you, at some point, if you take more physics, you're going to know how to do this anyway. So a couple things. When we talk about at an angle, we have this path, this parabolic path that it takes, okay? We can find peak height using an equation. We can find time of flight using an equation, and we can find range using an equation. Now I'm going to do these problems two ways. I'm going to do them using the kinematics equations, and I'm also going to do them using these equations where you can see where either one works. Just things you have to keep in mind when you use these equations here is that starting and stopping needs to be on the same y level. So we start at 0, we have to end on 0. We cannot start up high and end down low. That requires different math, and we have to use kinematic equations to solve that. But other than that, this is what we got, okay? So here's the first example. A football's kicked with initial velocity of 25 meters per second at an angle of 45 degrees with the horizontal. Determine the time of flight, the horizontal distance, and peak height of the football, okay? So again, I'm going to do it using kinematic equations first, and then go through the other three equations. So all we have is a football being launched at a velocity of 25 meters per second, and our angle to the ground on our launch is 45 degrees. Okay, and we want to find all this information, and this is all we need, which is awesome mathematically, because then we can figure all this out ourselves. Okay, so now first thing we want to do is write down everything we know. This 25 meters per second, it's not in the x and y yet. So we know that initial position in the x and y is going to be 0, okay? But our velocities we have to solve for. And this is that calculation from the first video you watch on projectile motion, where we look at the angles, right? Because if we want to find the initial velocity in the x, so x initial velocity, you take the overall velocity and multiply it by the cosine of our angle. Okay, and quick couple chugs of the calculator, and we get 17.7 meters per second. And with the y, to find your Vy initial, you get also 25, but now you multiply it by the sine, because the y is opposite our angle, the sine of 45. And since it's 45 degrees, we'll get the same answer, but that's how you find those answers. Okay, 17.7 meters per second. So we know our initial y velocity is 17.7, and we know our initial x velocity is 17.7. We also know our x acceleration 0, our y acceleration is negative 9.8, which means our x final velocity also is 17.7. And we want to find range, we want to find height, right? And we want to find total time. Okay, so let's start with finding, let's say we'll go in order, time of flight. So we want to find time of flight. So we know in the y, we know initial velocity is 0. We know our y initial velocity is 17.7, and our acceleration is negative 9.8. So to find time, we don't know final position, don't know final velocity. So we kind of look at our equations, and it's like we cannot find time right away. How about horizontal distance? Can we find that right away? And horizontal distance is xf. We know everything but time, okay? Because we know initial velocity, final velocity, but our acceleration is 0, which means we can't find xf. And so we're kind of in a conundrum here. You know, what can we find? Well, we know this. In projectile motion, in any projectile motion, at the very top, our velocity at the very top is going to be 0 in the y, okay? So if we know our initial velocity is 17.7, at the top it's 0, we can find the time, okay? We can find the time to get halfway. So let's do that, all right? So our final velocity is equal to initial velocity plus a times t. Final velocity is going to be 0. initial velocity is 17.7. Our acceleration is negative 9.8 times t. And we do all of our magic algebra, and here's what we get. So now we get the math, and we go t, I lost my marker here, t equals 1.8. Now, since that's halfway up, to get the full range, I just multiply it by 2 in 3.6 seconds. So that's my total time. So now I know my total time. And now, using kinematics, right, I know my total time is 3.6. And I want to find the horizontal distance. So I want to find my xf. If I want to find my xf, I just use this equation. xf equals x initial plus initial velocity in the x times time plus 1/2 at squared. Alright, now we know our acceleration is 0, so that eliminates this part. We know our initial position is 0, so exactly x final is just speed, velocity times time. So 17.7 times 3.6. When I do that math, I get 63.72, so 2 sig figs, we'll say it's 64 meters. Alright, so now we know that. So that's our horizontal distance or range. And now the peak height of the football. I want to go to peak height, and there's a couple different ways to do it. You could use either the VF squared equation or the XF equation, just using the Y components, right? I'm going to go ahead and use Y final equals Y initial plus initial velocity in the Y times T plus 1/2 AT squared. My final Y position is 0. My final Y position is what I'm solving for. That's equal to 0. So this is YF is equal to 0. Plus my initial Y velocity, which you'll recall from our work, is 17.7. Now with our time, we want to be aware our time is 3.6 for total, but 1.8 to go up, right? So I want to make this 1.8. So times 1.8. And then I add to that 1/2 times negative 9.8 times 1.8 squared. And again, it's just a bunch of button mashing. But at the end of the day, when you do all of this, you should get, if you keep track of your positives and negatives, you should get 16 meters. And that's our max height. Now, how does this relate to using the equation? So I'm going to start with the one I have here. Peak height. The peak height equation is VO y, so initial velocity in the y squared, over 2 times g. We're on Earth, so g is 9.8. So we'll substitute in our initial velocity in the y is 17.7, and I square that, and I take that over 2 times 9.8. And even though the decimal might be a little off, at the end of the day, you're going to get this answer when you round. And that's exactly what we saw here. So that's our peak height, okay? So let's look at our time of flight. Time of flight is 2 times initial velocity in the y over g. That equals 2 times 0.7, and that is over 9.8. And when I punch those numbers in, believe it or not, 3.6 seconds, which is our total time that we got initially. And then our last one, the range equation, a little more to talk about here, but I'll put the numbers in. VO squared times the sine of 2 theta all over g. So our VO squared would be this velocity here, okay, so 25. 25 squared times the sine of 2 times our angle, which is 90. 2 times 45 is 90. Over g, again, we're on Earth, 9.8. And we punch these numbers in, and we get 64 when we round. And you can see how this all fits together. So, the point is that you can use kinematic equations or range. Remember, you can only use these 3 equations. if you're on a flat surface. You start and stop at the same place. If you start up high, you have to go and use all the kinematic equations to solve. All right, so in essence of time, I'm going to give you this one to work on. Long jumper leaves the ground, initial velocity of 6 meters per second, angle 28 degrees above the horizontal. Determine the time of flight, the horizontal distance, and the peak height of the long jumper. Do the work. All right, do it with either the peak height, time of flight, range equations, or do it kinematically. I don't care. You should be able to do it both ways, but I'm not going to judge. And then I want you to put your answers here into the Ed puzzle, and then that'll be a way to check. Okay. Obviously, we round these answers, so your answers, make sure you round. Let's just round everything to, we'll say 3 sig figs. All right. So round everything to 3 sig figs with your answers. Okay. So for time of flight, horizontal distance, and height of the long jumper. Once you get those right, you pretty much know what you're doing. If you're struggling with getting these, come and see me so that we can get that taken care of. Happy problem solving.